And I'm going to share actually to a Word document just so I have a little more room to write tonight. Gives me a little more space to spread out here. So we only went over sections 5.1, 5.2, and 5.3 last week. And the last couple of sections are pretty tricky material. Now, to be honest, you guys as a group did very well on the WebAssign assignment. I was really impressed. Usually the last several groups I've had have struggled a lot on this week 11 assignment. You guys as a group, between all the sections I teach in this course, were 4.5 points above the average I've had for the last few semesters. So I was very, very pleasantly surprised to see that. You guys did way better than I had hoped you would. So you should pat yourself on the back for that. But anyway, we do have the final test coming up, and just to give you a warning, there are 4 or 5 questions on there about linear programming. All but one of them involve just the methods from sections 5.1, 5.2, and 5.3. There is one that involves the rest of the chapter. So that's what I want to go over tonight is an example of a question that deals with that. And the concept that is covered there is duality. And what duality really is, excuse me, is that it's saying that any minimization problem can be converted to an equivalent maximization problem. And this is not just multiplying by the -1 and changing it to a maximization like we talked about in section 5.4 with the non-standard problems. This is actually totally changing the equations and the constraints to get a new maximization problem that has the same results, that gives the same results as that minimization problem. And it actually gives the results within the slack variables. So to do this, we need to define what's called a characteristic matrix. And a characteristic matrix is very much like, if you're familiar with Cramer's rule, very much like the matrices used there, or a row echelon form for using an augmented matrix to solve systems of equations. It just contains all the numbers, all the coefficients of the variables without the variables. And the easiest way to illustrate a characteristic matrix is to put on a sample problem. So let's do this. Our problem is going to be to minimize the objective function c equals 2x plus y plus 2z, subject to the constraints. First constraint, 3x plus 2y plus z is greater than or equal to 100. Second constraint, 2x plus y plus 3z is greater than or equal to 200. And then, of course, we have the standard ones, x, y, and z are greater than or equal to 0. But those don't get put in our characteristic matrix. Our characteristic matrix, to do it, we're going to take first our constraint, and we're just going to rearrange it. We're going to put the variables first, 2x plus y plus 2z equals c, only we're going to let c be 0. We're going to put the constraints then at the top of our characteristic matrix. The objective function is going to be last. So at the top of our matrix, we have 3, 2, 1, and 100. That's just the coefficients from this first constraint. Remember, that's a 1z, and the answer, of course, in there as well. The second row of our matrix will be 2, 1, 3, and 200. 2, 1, 3, and 200. Again, we ignore the trivial constraints, the x, y, and z all greater than 0 or equal to 0. And the bottom row, the third row, is going to be then our objective functions, all that's left. So 2, 1, 2, and 0. 2, 1, 2. And remember, we said we put in 0 for C. This is that characteristic matrix. This is a 3 by 4 matrix. It has 3 rows and 4 columns. Now, a transpose of a matrix. Transpose of a matrix is row 1 becomes column 1. And of course, row 2 becomes column 2, and etc. So now one thing I should point out here is these constraints, first of all, this was minimization, so it's non-standard already, but these constraints are all greater than or equal to. That must be true. We must be dealing with greater than or equal to constraints for this duality to work. So now then, we're going to transpose this matrix here. So row 1 is 3, 2, 1, 100. So column 1 is going to become 3, 2, 1, 100. Row 2 is 2, 1, 3, 200. So column 2 becomes 2, 1, 3, 200. And row 3 is 2, 1, 2, 0. So column 3 becomes 2, 1, 2, 0. This transposed matrix actually defines a new linear programming problem. First of all, like I said, these all had to be greater than or equal to. All my constraints here are going to be less than or equal to. Now here I use the variables x, y, and z. I have to use different variables, so I'm going to use s and t. So this first row here is saying 3s plus 2t is less than or equal to 2. The second row is saying 2s plus 1t, or just t, is less than or equal to 1. Notice all these constraints are less than or equal to. The ones in the previous problem, our prime problem, were all greater than or equal to. This third row is saying s plus 3t is less than or equal to 2. And the final row is our objective function. And we've gone from minimizing to maximizing. So we're going to maximize this function. We'll just call it P. And it's 100s plus 200t. This is our new linear programming problem. And we need to try to solve this linear programming problem using our simplex method. How is my sound doing? Is it struggling there? I've got. Okay, somebody says a hand. Let me do this. I'm going to switch to a different mic. This computer sometimes struggles with the internal microphone when I have it in tablet mode. I'm going to put on a different mic here quick. Switched. Okay, does that sound better now? Does that a little bit more clear? Okay, sorry about that. I forgot that when I go in tablet mode, the microphone's actually on the bottom. It's on the keyboard of the computer, so it actually gets buried in the desk when I go into tablet mode. Okay, so back to this linear programming problem. We have to now solve this. And the only way to solve it, there's two variables. I actually could graph them if I wanted to. But that would not give us the equivalent dual problem. So in order to make this work, to give us the solution to the original problem, the prime problem, we have to use the simplex method. So that means I'm going to take this first equation here and I'm going to give it a slack variable. Now, since the variables I'm using here are s and t, which would normally be my slack variables, the slack variables I'm going to use are going to be the variables from the original constraints, x, y, and z. So 3s plus 2t, I'm going to add plus x will be my slack variable, equals 2. Now I'm leaving space there for my other slack variables. My second equation, it'll be 2s plus t plus y will be my slack variable there, equals 1. Then my third constraint will be s plus 3t plus z will be my slack variable there, equals 2. And then I'm going to do my objective function just like I would any other time. I'm going to subtract the s and the t to make it equal 0. So I've got negative 100s minus 200t plus p equals 0. So I'm going to use this. I'm just going to fill in the zeros here. And this is going to be used to create my initial tableau. So my first tableau, I'm going to use the variables or the column titles S, T, X, Y, Z, and P. And then of course, this will be my answers here. My first row is going to be 3, 2, 1, 0, 0, 0, 2. Now the slack variable used there is X, so I'm going to label this row X. My next row is 1, 3, 0, 0, oops, sorry. Picked the wrong row. My next row is 2, 1, 0, 1, 0, 0, 1. So that was this row. My slack variable used there is Y, so that's my Y row. My next row is going to be 1, 3, 0, 0, 1, 0, 2. Slack variable used there was Z, so that row is going to be labeled Z. Then my objective function on bottom, that'll be row P, negative 100, negative 200, 0, 0, 0, 1, 0. So there is my initial tableau. Now we're going to solve this using the standard simplex method, which means I find the largest negative number in the bottom row, which is the negative 200. So this is the column that I'm going to have to pivot around. In that column, I still need to do test ratios. So I use this number, my answer column, divided by the entry in the pivot column. 2 divided by 2 is 1. So that's my test ratio there. The next row, I have 1 divided by 1, which is also 1. Now remember, if we had test ratios that are the same, we just randomly pick one, arbitrarily pick one. Usually I'd go with the top row. But here, this next one, we've got 2 divided by 3, which is 0.667. That is smaller. So that is the smallest test ratio. We're going to pivot around that 3. So to pivot around the 3, I have to clear out all the other entries in that row. So the 2 has to go, the 1 has to go, and this negative 200 has to go. I have to zero them out. So I'm going to put my column labels back in here. My column labels, remember, never change. So it'll be S, T, X, Y, Z, P, and then answer. My first row then is going to be my X row. That label isn't going to change, but I do need to zero it out. I have to get rid of that 2. Remember, I always start out with the row I'm zeroing out is going to remain positive. And I need to combine it with my pivot row. So I got to combine the 2 and the 3 to make a 0. So I'm going to do 3 times X. The 2 is the entry in row X, minus 2 times Z. So the 3 is the entry in row Z. So it's 3 times row X, and then technically let's consider it negative 2 times row Z. Let's do this. We'll do 3 times X plus negative 2 times z. So let's go ahead. I'm going to multiply row x by 2. So 3 times 2 is 6. 4 times 2 is 4. Or sorry, 2 times 2 is 4. 1 times 2 is 2. Well, 0 times 2 is 0. And 2 times 2 is 4. I'm going to also do the same to row z, but it's going to be multiplied by negative. Oops, sorry. Let me back up. The x row, row x, gets multiplied by 3. Sorry about that. So 3 times 3 would be 9. 2 times 3 would be 6. 1 times 3 would be 3. Of course, 0 times anything is still 0. 2 times 3 would be 6. So row x is supposed to be multiplied by 3. Row z then is going to get multiplied by a negative 2 so that it'll cancel out the 6 in the t column of row x. So 1 times negative 2 is negative 2. 3 times negative 2 is negative 6. 0 times anything is 0. 1 times negative 2 is negative 2. 0. And 2 times negative 2 is negative 4. So now for that row, for row x, I have 9 plus negative 2 is 7. So that goes to 7. 6 plus negative 6 is 0. 3 plus 0 is 3. 0 plus 0 is 0. 0 plus negative 2 is negative 2. 0 plus 0 is 0. And 6 plus negative 4 is 2. So I've cleared out that entry in the pivot row or in the pivot column for row x. That's all I want to do is get that 0 right there. So I'm going to clear out all this little stuff here. So now I can focus on clearing out row y. So to clear out row y, I have a 1 and a 3, so I'm just going to do 3 times y plus negative 1 times z. So 3 times y, 3 times 2 is 6, 3 times 1 is 3, 3 times 0 is 0, 3 times 1 is 3, 3 times 0 is 0, 3 times 0 is 0, 3 times 1 is 3. So I just multiplied every entry in row x by 3. Then, of course, row z, I'm going to multiply by negative 1. So this is negative 1, negative 3, 0, 0, negative 1, 0, negative 2. So my new row y, 6 plus negative 1 is 5. 3 plus negative 3 is 0. Again, that's what we were shooting for, is to get the 0 in that pivot column for that row. 0 plus 0 is 0. 3 plus 0 is 3. 0 plus negative 1 is negative 1. 0 plus 0 is 0. 3 plus negative 2 is 1. So that's my new row y. So I'll clear out all those temporary numbers. Now row z is going to stay the same. That's my pivot row. But I am going to exchange the title of my pivot column is going to replace the title of my pivot row. So it's not going to be row z anymore. It's going to be row t. But the numbers are going to stay the same. So I'm going to put a t here, but it's going to stay 1, 3, 0, 0, 1, 0, 2. For row P, I need to zero that out, clear that out. I have to get rid of that negative 200 with the 3. Well, this one's going to be a rough one. It's going to be 3 times P plus 200 times Z. So 3 times row P, this would be a negative 300. This would be a negative 600. 0, 0, 0, 3 times 1 is 3, and 0. And 200 times row Z, well, 200 times 1 is 200. 200 times 3 is 600. Well, times 0 would just be 0. 200 times 1 is 200. Times 0 is just 0. 200 times 2 is 400. So now I'm going to combine those to get my row P. 200 plus negative 300 is a negative 100. 600 plus negative 600 is 0. That's what I wanted. I needed to zero out that column of that row. Well, 0 plus 0 is 0. 0 plus 0 is 0. So 0 and 0. 200 plus 0 is 200. 0 plus 3 is 3. And 400 plus 0 is 400. So there is my new Tableau. To tell if we're done or not, we always look at the bottom row. That bottom row still has a negative number in it, namely the negative 100. So that means we're going to be pivoting around that column, column S. We need to find our pivot row. We're going to do our test ratio. So we got 2 divided by 7. 2 divided by 7 is 0.285714, repeating. 1 divided by 5 is 0.2. 2 divided by 1 is 2. So our smallest is going to be the 0.2, so we're going to pivot around the 5 there. So we're going to pivot around row Y. So once again, we need to use that to eliminate the other numbers in that row. We're going to turn all those other numbers into zeros. I'm going to rewrite my column labels again. S, T, X, Y, Z, P, and answer. For row X, I have a 7 and I have a 5. So I'm going to do 5 times X plus negative 7 times row Y. So I'm going to multiply row X by 5. So 7 times 5 is 35. 0 times 5 is 0. 3 times 5 is 15. 0 times 5 is 0. Negative 2 times 5 is negative 10. 0 times 5 is 0. 2 times 5 is positive 10. And I'm going to multiply row Y by negative 7, as my formula says there. So 5 times negative 7 is negative 35. 0 times negative 7 is 0. 3 times negative 7 is negative 21. Negative 1 times negative 7 is a positive 7. 0 again, 1 times negative 7, this will be a negative 7. So my row X is found by combining those numbers. So 35 plus negative 35 is 0. Again, that's what I wanted to do, is I needed to zero out the entry in the S column. So that's what I needed there. 0 plus 0 is 0. 15 plus 0 is 15. 0 plus negative 21 is negative 21. Negative 10 plus 7 is a negative 3. 0 plus 0 is 0. 10 plus negative 7 is 3. So I'm going to erase those temporary numbers again. The Y row is my pivot row, so it doesn't change. The only thing that's going to change is I replace the row title with the column title. It's pivot row or pivot column S. So I'm going to move S down to be the title of that row, but the numbers are going to stay the same. So 5, 0, 0, 3, negative 1, 0, and 1. Row T, however, is going to change. I need to zero out the 1 there. To do that, since I have a 5 in row Y and a 1 in row T, I'm going to do 5 times row T plus negative 1 times row Y. So 5 times row T is 1 times 5 is 5, 3 times 5 is 15, 0 and 0, 1 times 5 is 5, 0, and 2 times 5 is 10. Negative 1 times row Y, so this will be negative 5, 0, 0, negative 3, positive 1, 0, and negative 1. So I'm going to add those entries. Negative 5 plus 5 is 0. Again, that was my whole purpose, was to zero out that entry, the entry in the S column of that row. 0 times 15 is 15, or 0 plus 15, I should say, is 15. 0 plus 0 is 0. Negative 3 plus 0 is negative 3. 1 plus 5 is 6. 0 plus 0 is 0. And negative 1 plus 10 is a 9. Well, I still have to do column P. So let me erase my temporary numbers here. to 0 at column P. Well, P is a negative 100. So I'm just going to do P plus, to match it up with a 5, I'd multiply times 20. So 20 times row Y. So row P is actually going to stay as it is. I'm going to multiply row Y by 20. So 5 times 20 is 100. 0 times 20 is 0. 3 times 20 is 60. Negative 1 times 20 is a negative 20. 0 and 1 times 20 is 20. So we're going to add here. This is row P. 100 plus negative 100 is 0. 0 plus 0 is 0. 0 plus 0 is 0 again. 60 plus 0 is 60. Negative 200 plus, or negative 20 plus 200 is 180. 0 plus 3 is 3. And 20 plus 400 is 420. Now we have reached the spot where there's all positive numbers in the bottom row. There's, or at least not all positive, but at least no negative numbers in the bottom row, which means we're done. We can read our answers. Now here's the part that's different. Since this is a dual problem, we read our answers differently. In a normal problem, we would find the value of x by doing s, the answer, divided by the value in the x column. That'd be 0.2. Well, that would be the answer for the maximization question up above. And of course, x is just a slack variable. We would actually be dealing with the s. So it'd be 1 over 5 is 0.2 for s. 9 over 15 would be 0.6 for t. But we're not trying to solve the maximization problem. We're trying to solve that original, the prime problem, the minimization problem. To do that, we have the original variables were x, y, and z. Those values are found by taking the value at the bottom of those columns. So the solution for x is going to be the 0 divided by the PP entry. This is row P, column P. So it's the 0 in column X, the bottom of column X, divided by the 3 in the bottom of column P gives x is 0. For y, there's 60 at the bottom of column Y divided by that 3. 60 divided by 3 is 20. So y is 20. Z, the entry in the bottom of column Z is 180 divided by the PP entry. So 180 divided by 3 is 60 for Z. And our minimum is going to be this entry, the answer entry, divided by that P again. 420 divided by 3 equals 140. So the function's minimized at 140 when x is 0, y is 20, and z is 60. Now we're going to double check that answer by using x, y, and z values that we got here in that original minimization problem. So the original minimization problem was to minimize c equals 2x plus y plus 2z. So we will put in 2 times 0 plus y is 20 plus 2 times 60. 2 times 0 is 0 plus 20. 2 times 60 is 120. That does add up to 140. So we get the same result plugging in that solution to our objective function as we did from the Tableau. So we minimize that function at a value of 140 when x is 0, y is 20, and z is 60. It's kind of interesting that that works, and there's some pretty complex mathematics behind proving that it works, so I'm not going to get into it, not going to confuse you with it. I wanted to leave the rest of our time here then open for questions. They are very lengthy and complex, and unfortunately, the TI-84 does not do them, and Minitab does not do them. But I can show you something here quick on the TI-84 that might be a little bit of assistance. Actually, on this computer, I only have the TI-83, but that'll still work. Let's say you have constraints like 2x plus 3y equals 12, or less than or equal to 12, and 6x minus y less than or equal to 6. And you need to find out on the graph where those constraints cross. Well, what you can do is you can turn them into equations or treat them like equations and just enter them into the TI-83. Here, let me share. Come on. I have to do the calculator here. It won't give me the whole screen. Oh, there we go. I can do the whole screen there. So you should be able to see my calculator pop up on the screen here. So what I'm going to do is I'm going to go to matrices. So second, matrix, edit. Now I'm going to put it in, this is a there's two equations, so 2 rows and 3 columns because I have an X, Y, and then the answers here. Then I'm just going to put in 2, 3, and 12. That's my first equation. Second, I'm going to put in 6. Now for -1, make sure you use the negative key down here. Try to use -1, it's going to give you an error. And then 6. I'm going to do second quit. Then I'm going to do second matrix math. And what I'm going to do is I'm going to go all the way down here to RREF. RREF stands for reduced row echelon form. Then I'm going to do second matrix again and select the name A. I want to find the RREF of matrix A. That's where I put these equations. And what it gives me here, this 1 is in the first column. That's my X variables were in the first column. So that's saying that X equals, the number at the end of the row is the solution. X equals 1.5 and Y equals 3. So these intersect at the point 1.5 and 3. So that might save you some time finding the intersections of your constraints, at least on the graphing problems. When you're doing the exam, to know whether you can graph, if there's only 2 variables, you can graph. Of course, we only have 2 variables, 2 dimensions on our graph. So if you have a problem that can be reduced to 2 variables or is 2 variables, you can graph it. If it's 3 or more, well, then you have to use the simplex method. I will give you one hint. I might be pushing it a little far here, but the one that you have to use duality, it'll say use duality to solve. It'll put that word right in the problem for you if it expects you to use duality. Okay. What do you put in the parentheses? Then you have to do second matrix, and you have to select under the names, you have to select A. So that'll tell it to use the RREF of matrix A. So once you've got your, it could be a different name. If you enter your equations in a different name, you could use whatever name you entered the equations into, whatever matrix you entered them into. I always put them in the first one, so it's matrix A. Yeah, the simplex method is perfect. I'm glad it worked, Evan. So it is time consuming. What I would recommend is you maybe leave some of those till last. There might be time constraints on the test. I've had some people say that the 3 hours only turned into like 2.5 because of time constraints with ProctorU, trying to get everything done, logging in and everything. They only had 2.5 hours left. Apparently the system starts the clock when you start to log in, not once you get logged in. So that's a WebAssign issue. I actually have a meeting coming up in early January to bring that up to our WebAssign rep. That even if you just log in and you're sitting on the page waiting to put in the password, it starts the clock on you. So don't log in and try to access the test before your time to start. Log into ProctorU, get everything set there, and then with your ProctorU people on the line, then log into WebAssign and get that all done. Otherwise, you lose minutes on your test. I will tell you that the questions on the test are put in order of chapters. You should be able to look at the top and see what chapters. You can see that the ones that say, oops, lost it here. At the top of the question, if they say PodStat, those are the ones out of the regular textbook. If they say Wayne, W-A-N-E, those are the ones that are out of the linear programming textbook. So it should be pretty easy to tell which ones are linear programming. You should be able to use Minitab. I haven't had anybody report back that they haven't been. I've had 6 people take it so far, and nobody has complained that they weren't able to use Minitab. So I'm hoping that says it will work. It's supposed to. The main issue we've been having is just the timing and getting logged in, and network issues, having to refresh because of network clogging down. WebAssign is reacting a little slow, and ProctorU is having some bandwidth issues as well. If your practice test is locked up on you, send me a message and I will reopen it for you. I have to reopen those individually. I can't just do those mass for the whole class. Something, the way they were set up in the system doesn't allow me to reopen them for everybody. So yeah, Dustin, if you want to look at it, just send me an email and I'll get that done for you later. Any other questions? You guys have been a great group. Like I said, you really pleasantly surprised me on this linear programming and the content. You guys have done extremely well. I'm very happy. It's been a pleasure to work with all of you, especially in these troubling times. Some of my other classes have struggled with the changes that have had to be made to accommodate everything. So it was really, really nice to work with a couple of groups here that thrived in this. So it's been, like I said, you guys have been a joy, put it that way. It's been a blessing for me to work with. Good luck on your exam. If you need anything, well, thank you, Neil. If you guys need anything, let me know. I have free time tomorrow. Let's see, I'm on Central Time, so I'm translating here. It'd be from 10:30 till about 1:30 your time. I have a 3-hour window in there that if you need any assistance, you can let me know and I will be able to meet you in Meet or whatever. Any emergency issues come up with the test, my phone number, 715-642-1213. So don't mess around. I mean, your first ProctorU's first line of defense is always to try to call the testing center, but they are overloaded with calls. So if they don't get an answer at the testing center, please feel free to have them call me direct, and I'll see if I can straighten things out with them from there. With that, you guys have a great holiday coming up here. Enjoy your time off and good luck on the exam. Good luck in your other classes next semester. You guys have a great night as well. That shouldn't be an issue, John. As long as you didn't access your final, it shouldn't be an issue. If you did try to access the final, here, let me double check right now. I've got the system up on my other screen here. Nope, it's showing you have the full time left, so it shouldn't have affected your final. So you should be good.